Today we are going to start with the next topic, that is string matching algorithms, right? So various algorithms used for the matching of the strings. See, in the real life, every day we are using so many applications where we need to search for a particular kind of a like whenever. So the popular example is like you are using the Google search engine where you are writing the query like for any kind of, if any topic is not understandable for of the topics that we have been studying, or if you have any query regarding you are searching for your where you are searching for a new song or whatever, anything, you know, you are using the Google search engine for finding out the various relevant URLs where you can find the details or some information. So whenever you are writing a particular query, you are basically pass a string, right? So that is a character string, and this and the Google is providing you the documents which match that particular string. So just understand, we say that the size of the World Wide Web that is measured with the raw data which has been crawled by the Google search engine. So and having, you know, zettabytes of data or petabytes of data, having so much of huge data, and then finding relevant documents from that amount of the from the petabytes of data, and matching that particular string. So that means relevant data is the only one that is matching with the query string that we have passed. It may be you are just passing the one word, or you are passing multiple words in the form of a query. And the Google is matching all those terms, and you are getting the results in the milliseconds or the microseconds. So you can understand the strength of the algorithms which have been used for processing a particular query. So basically the task that you do when you're writing a query, that is basically the pattern searching, or you can say the string matching task that is being done at the back end in order to provide you the relevant documents. So let us understand the various algorithms which are used for solving such kind of problems. That is in order to find the matching strings. And similarly, the other applications are like for the DNA sequence, where they are trying to find out the similar kind of DNA sequence which is available, so that they can so finding the DNA sequence, they helps in this, devising the new medicines, or you can say the new treatments for the patients, right? So they are used for the multiple applications if they are able to find a particular kind of pattern into the DNA sequence. So when they are trying to find out a pattern in the DNA sequence, basically that pattern is nothing but a string that we are searching for. So we have similarly in the surveillance also, when when the people CPI or other companies, they are inquiring for a particular case, they are searching for the strings which are relevant to them, and then again the task at the back end is the string matching. So let us understand the various algorithms which are used for matching the strings. So the various string matching algorithms that we are going to discuss in this particular course, they are the naive string matching, finite automata matcher, Rabin-Cobb matching algorithm, Knuth-Morris, Pratt, tries, suffix tree, and suffix array. So we are going to discuss all these algorithms one by one. So what is the problem when we say we are going to study about the string matching? So the problem is like you are given a text array like T1 to T10, so let us say when I gave you the example of your Google search engine. So what you have the text. Text is the text that is given in all the web pages. So let's say you're looking for academic site. So GIT is one of the websites. So whatever text is being written over there, so that refers to the text. You can say, we can imagine it as a big array, right? And the pattern is the text that your query that you are looking for, that you are searching into that particular text. So you can say, given a text array and a pattern such that the elements of T and P are characters, right? So they are the characters which are taken from the alphabet. So alphabet is basically the sigma that we are saying. This is the set of characters which are there. Let us say if I take the query pattern. So in this particular pattern, let us say my query is pattern only. So if you see how many characters are there. So we say PATERN. ERN. So we are not going to consider. So here you can see where we are basically talking about the unique characters which are there in a particular word. So your sigma refers to the unique characters which are there. So maybe our query string is pattern that we are looking for into a particular string, but the characters which are there, they are only PATER. So T is repeated. So we can say if the size of this is 7, so 7 is the size of the string. But the characters which are included are PATER. So the string matching problem is to find all the occurrences of P in the T. So we are going to search, say in the machine learning, or you can say in the information retrieval systems for your in your upcoming semesters, where you are going to study many courses where you are going to study the algorithms which are used for finding the patterns. Right, so you are going to what you will be studying the web algorithms in the information retrieval, where you will study the vector space model, or you can say the different sine cosine functions which are used to find the similar documents. So whenever you are looking for the similar documents, so you are matching the terms. So when you are matching the terms, so you are going to whenever you do the text summarization, what are you going to do? You are looking for the frequency. So how many times pattern is occurring in this particular web page, or how many times Java is occurring in this particular web page. So that is the frequency that we are searching for, that in the given text what is the frequency or how many times it is occurring. So here we are restricting for the time being, for understanding these algorithms, we are going to restrict that to a small text, right? And then we are trying to find out a very small pattern within the text, that how many times it is going to occur. And we have to find out the indexes of so we are assuming over here the text is stored in the form of an array, and then from that particular array, when we are searching for a particular pattern, so in that text how many times it is occurring. So we want to find out the you can say the index of all the positions. So like you have been studying the searching algorithm, what we were searching, so we were searching any numeric values, or you can search for any text also. So here we are, what we are searching for, we are searching for the patterns, right? So we can say a pattern P occurs with shift S and T. So how do we search basically? See, when we are searching for a particular pattern, so we have to see here, when we were studying about the subsequences, we were not studying about the pattern. So in the subsequences, we were searching for the sequences, but they were not in the consecutive positions. But in the string matching algorithms, when we are searching for a string, so that means all the characters in a particular word, they must be consecutive to each other. Only then we say it is a string, and then we are trying to solve this particular string matching problem. So you can say here we have a text B, A, C, A, B, C, A, B, right? So here you see, sorry. Here we have B, A, C, A, B, C, A, B, C, A, right? So from this text, we are trying to search for a pattern C, A, B, C. So how do we start? We start from the very first position, as you see with the help of this particular example. Before this example, we just have to understand a small thing, that a string W is a prefix of X if X is equal to WY for the some string, and similarly W is a suffix if X is equal to YW for some string Y. So the first algorithm that we are going to study for the string matching problem is a naive string matching. So in the naive string matching, what do? The simplest thing that we have been doing, that is basically called as the naive string matching algorithm. The basic technique that we follow in order to find out a string from a given text. So given a string text from 0 to n minus 1 and a string pattern from 0 to m minus 1, where the size of the n is always greater than the size of m, then we have to find all the occurrences of pattern in the text, right? So text is today is a good day and pattern is good. So the output pattern, we know what is the position of good. So you just count the character and see from where it starts. So we have good at the index 11. Similarly, for the input, a friend in need is a friend in need. We are looking for the pattern friend, and it's the, we know in this particular string, friend is at friend is occurring twice. So friend is once occurring over here, and the friend is again occurring over here. So pattern first pattern is first found at the index position 2, and then the pattern is again occurring at the index position 22. So this is basically the task that we are trying to do when we are trying to solve the string matching problem. So now we'll see how the name string matching algorithm works. So in this particular approach, let us say we have a text. So in this particular text, we have A, B, C, A, B, D, A, B, C, D, E. So it is some vague text that we have taken. So and we are searching for the pattern P, that is A, B, D. So what do? We start matching from the very first position, that is the 0th position, let us say, in the array. So we say A is equal to A, yes, but D is not equal to C. So there is a mismatch. So then what do? We again shift the index position of T to the second position, and then we again start the search. So we have a mismatch after 3 comparisons. Then we again start the search from the second position on the text array. Right now, again, what do? Again we do B is equal to A, no, so there is a mismatch after the first comparison. Then we move next. Again A is equal to A, yes. B is equal to B, yes. And D is equal to D, right? So sorry, there was one step missed. So here we after the B A, so we are going to compare with A and C, right? So C, A is not equal to C, so there is a mismatch after one comparison. So we again shift, right? So we again shift to the next position, and then see, every time, see, we are starting the search of the complete pattern from the initial position only, and then we are shifting when there is whenever there is a mismatch with any of the characters at any point, whenever, whether the mismatch is found at the first position only for the first character A, so we shift the array index of the text to the next position. So this is how we perform this particular, you can say, the searching for a pattern in the text using the naive-Bayes approach. So after this comparison, we see A is equal to A, B is equal to B, and D is equal to D. Yes, we are able to find the match after 3 comparisons. And how many before? See, in total, how many comparisons were performed in order to find out this particular pattern? We can see we have performed 8 comparisons. The string P is found in T after the total number of 8 comparisons. So after this, so we think that what is the time complexity, what is the worst case running time for this. So here you say, if we have a text like this, right, so that means we are trying to understand what is the problem with this particular technique or this algorithm of string matching. So let us say, because we see, we cannot say what kind of text we are going to get. It can be of any type. So let us assume that this is the kind of text that we have TAAA, and in the last we have a mismatch. Last we are going to, so that means we are going to get the pattern at the end of the text, right? So you can say that may be the worst case. So for a pattern of size 4, then how many comparisons we will require? So here we can see we have a mismatch after the 4th comparison, and every time we move, there is a mismatch after the 4 comparisons. And finally, see, when we reach to the end of the string, which is, let us say, the length of the string is n, then we are able to find out a desired pattern. So how many comparisons we have performed in such kind of, you can say, text that we have come across. So this will continue. We can see this will continue to happen until n minus 4th alphabet in T is compared with the characters in T that we can see. Thus, the number of comparisons we can see they are required is n minus 4 into 4 plus 4. So this is the number of comparisons which are required in the worst case running time. So at every step we know after m comparisons, a mismatch will be found. So we have seen after 4 comparisons there was a mismatch. So let us say there were that is equal to m. If these m comparisons will be done for n minus m characters in T that we have seen. See, we are just generating a formula for this particular problem. Thus, the running time obtained is n minus m into n plus m, as we have seen with the help of this example. So thus, due to this running time, so this particular, you can say, for the for a large amount, when the size of the text is large, this algorithm is not suitable for pattern searching technique, or you can say finding the patterns in the text. So the naive based algorithm, you can say this naive algorithm is not suitable for solving such kind of problems when the size of the text is large. So the same concept that we have done here, it has been written in the form of a pseudocode. So here you see for int s is equal to 0 to n to minus m. So from the first array will start from 0 and it will go till n minus m, because we have to find the pattern. So m is the size of the pattern that we are searching for. Then for another array will move to the length. See, we will have one for loop which will traverse through the complete text, and the second for loop that will traverse through the pattern. So when we are searching for this, so if text of s plus j not equal to pattern j, we will break the loop and again we will start from there. And if j is equal to m, then we are going to print the pattern. So at every stage we are going to start from the next position, that means from the second index position, from the third and nth index position. So from here we can see that the complexity, since there are four loops, one is of size m and another is of size n, so the time complexity of this naive string matching algorithm is of the order of n into m. So now